Okay, so this is section 5.5, integer exponents and the quotient rule. And so this section will be about using negative integers as exponents. So if you take a look, we learned the other time that 5 to the 0 power turned out to be 1. And so we want to take that a little bit further. We want to go with negative exponents now. So let's take a look at the power of 2. So if we have the power of 2 to the second, 2 to the 1, 2 to the 0, 2 to the negative 1, 2 to the negative 2. What does this look like? Well, first of all, 2 to the second is 4. 2 to the 1 is 2. And we know that 2 to the 0 is 1. And so as we go downward, we see this pattern. 4 divided by 2 is the 2. And then the same thing here. 2 divided by 2 is 1. So now when we go to the next one, it's the same thing. We're going to take 1 and divide it by 2. Okay? And so that gives us 1 over 2, or a half. And the same thing goes for the next one. We take a half and divide it by 2. Well, that's really 1/2 times 1/2. And so that becomes 1/4. And so you can see this pattern of what's happening. And so that's what we're going to be studying now. So the rule for negative integer exponents, so negative integer exponents, okay, the rule is you have a to the negative n is the same thing as saying 1 over a to the n. And that's the same thing. We could say 1 over a to the n is the same thing as a to the negative n. So they go backwards and forwards in this. So for example, if I have 2, and that's to the power of negative 3, okay, I'm going to take this and turn it into this. So now it becomes 1 over 2 to the third. You see how it matches this general form? Okay, so if that's the case, then we can go a little bit further and finish it, because 2 to the third is 8. So we're looking at 1/8. Okay, let's do 7 to the negative 1. Well, that's really 1 over 7 to the 1, which is just 1/7. Okay. And then the same thing goes for, let's do it over here. We have parentheses x plus y, and that's to the power of negative 8. Well, we transform it into 1 over x plus y to the positive 8. And so this is how these problems work. Okay? And so let's take a closer look at when we start to simplify exponents that are with positive or negative exponents. So let's take a look at, let's say, 5 to the second multiplied by 5 to the negative 4. Well, again, let's rewrite this one so it doesn't have a negative exponent. So that becomes 5 to the second over 1, and then this becomes 1 over 5 to the fourth. So again, I have two 5's here. So 5 times 5 is in the numerator, and there are 4 in the denominator. So now I see that I can simplify, because this 5 divided by this 5 is 1, and this 5 divided by this 5 is 1. So 1 times 1 is 1, but I still have two 5's in the denominator, so 5 times 5 is 25. So 1/25 is my answer. If I look at a different problem like 3 to the negative 2 and multiplied by 3 to the negative 1, both of these are going to get moved. So that's over 1. So I'm going to rewrite it as 1 over 3 squared multiplied by 1 over 3 to the 1. And so now I have 1 over 3 to the third, because there's 2 here and 1 here. And so that's really 1 over 27. And so these are the kinds of situations that you have. So let's take a look at with problems that have variables in it. Okay, so I'll draw a line so you can separate that. Again, if I have x squared and I'm multiplying it by x to the negative 5, it behaves just like numbers, because this is over 1 and this is over 1. But since this is positive, we leave it alone, because that's what we want to keep. And then the other one is not, so we have to switch it. So that's 1 over x to the 5th. And so now I have x to the 2nd over x to the 5th. And so I have 2 in the numerator, and then I have 5 in the denominator. So this cancels to 1, this cancels to 1, and so now I just have 3 in the denominator and 1 in the numerator. So x to the 3rd, 1 over x to the 3rd. And this is just another setup, okay? So let's say we do a different thing. Let's say we have parentheses y to the 3rd power, and that's to the negative 4th power. So again, we can go ahead and multiply these. Since 3 is positive, that's y to the negative 12. And then this is over 1, so I'm going to move it down, so that's 1 over y to the 12th. Okay? And let's look at RT, and it's all to the negative 5. Again, this is all over 1, so that would make it 1 over r to the 5th t to the 5th. And then our last one we'll look at, this one a little bit more crazier. We have AB, and it's all to the negative 3 power. Alright, and then we have A, which is to the negative 2, and then B to, that's it, and then with the 3. Alright, so this one here is over 1, but since it's negative, I'm going to rewrite it as 1 over A to the 3rd, B to the 3rd. This one, the 3 goes to the 2, so that means it's going to be, and the 3 is going to go to the B, so that's B to the 3rd, and then this negative is going to force the A to go to the denominator, and that's to the 6th. So we can see that the B's cancel, and so they get 1. So we have 1 in the numerator, and then A3, A to 6 would make it A to the 9th. And so this is how these kinds of problems are done. You have multiple rules to think of, and now that you're looking at negative exponents, you have to start thinking about how to move them so that they're no longer negative.